I'm going to prove that A intersection with all in the brackets of not is not A intersection not B equals A. So the best way I find when doing sets is to show myself that this will equal A with Venn diagrams, just so I can get an image in my head of what it is and how it actually works. So best way to do that is so you start with the inside bracket, so you've got not A intersection not B, which is all this in the background. So then you do just outside the bracket. Which is A not B all not, which will be all this inside here. Then the final part is the entire equation. Which is A intersection A not A not B not, which is this intersection with A, which is just A. So now I know that it actually works. I have to go actually prove it mathematically, because this is not a proof. It's too vague. So you use the set operation laws, which you have, to work this equation so it equals A. So the left-hand side is A intersection A not B or not. So that's what you start with. So best way is you always start with brackets, which is how I always worked. So A intersection, use De Morgan's law, which is this one, with the complementary, but not complementary, not. So that becomes not union with not. So you have that all in the brackets. That's De Morgan. So then not something is saying as it is something. So they cancel each other out, and you have A union B, which is double complement. Now my first instinct when I see this is to go straight to a distributive law, which will have you going A, because it's this one, would be my first instinct, would be A intersection A union B, which would then give you A union B, intersection B. So effectively all you'll be doing is going around in a loop. So before you start that horrible little cycle, you break the loop back up here by realizing that A can be equivalent using the identity laws up here. So to pick the identity law is you want to have it so you can use the distributive law. So you need to have it as a union of something, which is A union of the null set. So that is A union the null set intersection A union B, which is the identity. Okay. So then you can go to town using the distributive law. So because you've got the intersection here, so you'd use this one. So it's A union the null set intersection with B, which is So then look in the brackets again. So anything with the null set intersection will be equal to the null set, which is the domination law. So it's A union the null set, which is the, that's not how you spell it, but no one cares. So anything that's now unioned with the null set is that, which is identity. So then you have A is the right-hand side, so that equals the right-hand side. So then we have proven that A intersection of A not B equals A.